In today we are going to see about asymmetric key cipher. We discussed about advanced encryption standard algorithm in previous class. So today let us see about in detail. We discussed that it is a highly trusted encryption algorithm used to secure data for converting into an unreadable format without a proper key. So that is said to be your advanced encryption algorithm. So here it is also called Ridgedale, a symmetric block diagram with a block length of 128 bits. So we studied that AES, that is as a advanced encryption standard, is a block cipher, and the key size can be 128 or 192 or 126. So here the encrypted data in the block is of 128 bits each, which means it takes 128 bits as an input and output as 128, which is an encrypt of ciphertext. So this is the basic building blocks of advanced encrypted algorithm. So the main working of this algorithm is that it operates a byte of data rather than in a bits, which means the block size is 128 bits. The cipher process 128 bits, that is said to be your 16 bytes of input data at a time. So for example, the number of round is 10, the key size will be in bits, it's about 128. If the size of number of round is 12, then it will be around 192. If the number of rounds is around 14, then the size will be 256. So let us see about the creation of round keys. Okay, so the key schedule algorithm calculates all round keys from the key. So initially the key is used to create many different rounds, which is said to be which will be used in corresponding round of encryption. So here the K0 to Kn are the various round keys, and it depends upon the round. Okay, so next let us see about the encryptions. So your algorithm consider each blocks of 16 bytes, which means a 4 byte into 4 byte, that is 128 16 byte grid in a column major array arrangement. So here from B0 to B15. So each round comprises of 4 steps, that is sub bytes, shift rows, mix column, and add round key. So the main thing is you have to remember that each round comprises of 4 steps. One is your sub bytes, shift rows, mix column, and add rows key. So in your sub bytes, so in this step, each byte is substituted by another byte. It is performed using a lookup table that is called S box. This substitution is done in a way that a byte is never substituted by itself, and also it is not substituted by another byte which is complicated of current byte. This is the first basic step in this algorithm. Next is your shift rows. Shift rows is something that the first row is not shifted, and the second row is shifted once to left, and the third row is twice shifted to the left, and fourth row is thrice shifted to the left. Okay, so these are the basic thing. So in this diagram you will be clearly see about how the rows are shifted. And third thing is that mix column. So mix column is something that it is a step is used mainly for matrix multiplication, which means each column is multiplied with a specific matrix to position of each bytes in the column, and it changes the result. And the last one is your add round key. So the resultant output of the previous stage is XOR. So it is XOR and with the corresponding round key. See this diagram, it is XOR to obtain the result. So here 16 byte is not considered as a grid, but it is just in 128 bits of data. So after all these rounds, 128 bits of encrypted data is given back as output, and this process is repeated until the data to be encrypted. So next, these are the process. This diagram will explain about the process, how the data has been shifted. And next is how shifting rows are occurred. See in this diagram how the rows have been shifted. Next is mixing. This is an example of mixing column. And next is about AES decryption algorithm. So in this stage, it can be easily done, where it performs an opposite operation, that is reverse operation. So here each 128 blocks goes through 10, 12 and 14 rounds. So here also the decryption process consists of 4 rounds, that is add round key, inverse mix column, shift rows and inverse sub bytes. So in inverse mix column, so here the step is similar to the mix column and step into the encryption, but differs in matrix. It is used to carry out the operation, and mix column operation of each column is mixed independent of other, and matrix multiplication is used. The output of the step is matrix multiplication. Next is inverse sub bytes. Inverse S box is used as a lookup table, and using which the bytes are substituted during the decryption. So next is a shift rows. So shift rows performs a circular shift in opposite direction of each of the last 3 rows, and these are the rounds which is performed in AES. So let us see application of AES is something that it is wireless security and database encryption, and it provides a secure communication and also data storage, and it provides a virtual private network. So these are the main application of this algorithm. So if you have any clarification or doubt related to this topic, please feel free to contact me. Thank you.